Okay, girls, so for the first part of this test, we have 16x to the power of 4 minus 686x. Now, you should recognize that we haven't done anything with an x to the power of 4. An x to the power of 4 and an x in it. So you have to manipulate it so it looks like something that we've done. So in this case, you should recognize that all I can do is factorize out what's common. So what's common to both of these terms is 2x. So all I can do in the first part of this question is factorize out 2x. 2x into 16x to the power of 4 is 8x cubed. 2x into minus 686x is minus 343. And now at this stage, you should recognize that what I have in my brackets is the difference of two cubes. And no one had any excuses for not remembering the formula, because I gave you so many hints on this one. So you should recognize that rather than calling this 8x cubed, we can actually view that as 2x to be cubed. Rather than calling this 343, I can actually say that's 7 to be cubed. Now, our formula for the difference of two cubes is that a cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. So that's basically just your learning work. You should know that going into the exam. In this case, clearly my a is going to be 2x and my b is going to be 7. So I just need to rewrite these two brackets, except instead of an a, it's 2x, instead of a b, it's 7. Which means my final answer here, I can just sub in. My first bracket is a minus b, so it's 2x minus 7. My second bracket will be a squared, which in this scenario is 2x to be squared, plus a by b, so that's plus 2x times 7, plus b squared, which in this case is 7 to be squared. And now all we can do here is square this term and multiply the thing in the middle. So I can leave this as 2x times 2x minus 7. Then 2x by 2x is 4x squared. 2x by 7 is 14x. 7 by 7 is 49. So my final answer in that scenario are this is the factors. That's factorized fully. Now I want to go through the marking scheme. So in this question, the marks were 0, 2, 3, or 5. Okay, so I want you to think about what I'm thinking when I'm correcting this. If when I glance at your page, it looks like it's nearly perfect, if it looks like you've got it right, but there's just one thing wrong, then in my head I'm starting you off at 5 marks. If it looks right, I'll start you off up here. And for every mistake that I can find, I'll bring you down. So if I can find one mistake, I'll bring you down to 3 marks. If I can find 2 mistakes, I'll bring you down to 2 marks. And another mistake, then you're on 0. The alternative to that is, let's say I glance at this and it looks almost completely wrong. In that scenario, I'm starting you off at 0 marks. And then I'm looking for, is there one thing that you did right? So for a lot of people, what that one thing might have been was they factorized out 2, or they factorized out 2x. So if I can see one thing that you've done right, I'm bringing you up the scale. For everything that I can see that's done right, I think a lot of you factorized out your 2x, but didn't get any further. So for a lot of you, that's your 3 marks. Okay, part 2, or part B of this question, there's 10 marks going. My marking scheme in this case is 0, 3, 5, 7, or 10. I'll talk to you about that again when I finish it off. At this point, you should recognize, right, I have a log to the base 2, a log to the base 2, and a 5. So clearly my problem is the fact that I have a 5 here. This term just doesn't seem to belong. So because this is a log to the base 2 and this is a log to the base 2, clearly I need the last one to become a log to the base 2. So instead of a 5, I need to sub in a log to the base 2. So I know, right, it has to be this and it has to be equal to 5. So it has to be log to the base 2 of something equals 5. So let's say we start off, let's just call it x. So I know the base to the power of the answer gives me x. So in this case, I can say that 2 to the power of 5 equals x. If you plug that into your calculator, clearly x in this scenario must be 32. Which means that instead of subbing in a 5, I can just sub in the log of 32 to the base 2. Because the log of 32 to the base 2 is the same as 5. So I can just rewrite my entire line. I get the log of x plus 2 to the base 2 plus the log of x minus 2 to the base 2 equals, instead of my 5, I can just sub in the log of 32 to the base 2. Now, a lot of you, for some reason, went wrong in the next line. A lot of you treated this as if that was a minus, okay? At the moment, I have log of x plus 2 to the base 2 plus the log of x minus 2 to the base 2. So I need to use my first rule of logs to simplify this. So in order to use my first rule of logs, it says that if I have log of x plus the log of y, I can just multiply this by this. Whereas a lot of people treat this as if it was a minus, so just make sure you're summing into the right formula. So if I use my first rule of logs, I can just multiply x plus 2 by x minus 2. So I can just make that into one log and multiply each of my brackets. And that's equal to the log of 32 to the base 2. Now at this point I'm happy. The whole point of everything we've done so far was to get to here. If I have one log on the left, one log on the right, with the same base in each case, then I can just cancel out my logs. So now my logs are gone, I just have a normal algebraic equation. I have x plus 2 multiplied by x minus 2. So that's double brackets. And if you multiply that out, you'll get x squared minus 4. Again, just make sure you're getting that right. I do that in rough work. Multiply the first thing by the second bracket, the second thing by the second bracket. So I get x squared minus 4 equals 32. Now, I want to first show you the way that every single person in the class solved this one, and then I want to show you the way that you should have done it. So there's not a single one of you did this the correct way. Okay? Now, a lot of people got full marks, but it was by fluke as opposed to design. So I want to show you first the way that you did it, and then the way that you should have done it. So what the vast majority did here was they bring their 4 to the other side. When you bring 4 to the other side, it becomes plus. So I get x squared equals 32 plus 4. So I get x squared equals 36. So I get x is equal to the square root of 36 is 6. And that was the correct answer in this case. But that is not the way you should have answered this question. And it kills me that I had to give everyone full marks for that. It was fluke as opposed to design. In this question, based on the marking scheme, you do get full marks for that, but you usually won't. I want to go back to this sign. If I have x squared minus 4 equals 32. So what you should have done there is you should have brought the 32 to this side. Because I have x squared, that'll be minus 4 minus 32 equals 0. Which means that I get x squared minus 36 equals 0. The reason we're doing this is because you should recognize if it's x squared that you should get two answers. There's an x squared in it, that means there's two answers. And you should view x squared minus 36 as the difference of two squares. And now I can just factorize this. The factors of x squared minus 36 are x minus 6 times x plus 6 equals 0. So the square root of x squared is x, so x by x equals x squared, minus 6 by plus 6 is minus 36. So that was the correct way to do this. I'm running out of space, so I'll just finish it off up here. So now I want to solve it. I would say that x minus 6 equals 0, which means x equals plus 6. And I could say that x plus 6 equals 0, which means that x equals minus 6. So your two possibilities are x equals 6 or x equals minus 6. Now, in this scenario, clearly x can't be minus 6. Because minus 6 plus 2, that would be a minus 4. Minus 6 minus 2, that would be a minus 8. And we know that this value here cannot be negative. So it was just lucky that the way pretty much every single person, there wasn't a single person who did it like this. All of you ended up doing it like this. And doing it like this only works. You only actually get one value. If any topic in maths, if you have an x squared, you need to get two answers. Now technically it's accurate for you to say, if you were down here, you said x squared equals 36, you could then say that x is equal to plus or minus 6. But realistically, you're going to forget to do that. Remember, the square root of any number, there's always two answers. But in the vast majority of questions we do in maths, we actually end up ignoring one of them. I'm sticking on this too long. All I want to highlight is you should have answered that question like that, and you would have got your answer as x equals 6, and you would have eliminated the x equals minus 6 answer. But luckily, everyone got full marks for that in that scenario. Okay, so for part C of this question, first of all, I want you to notice that my marking scheme is the exact same. I have 0, 3, 5, 7, or 10. You have 2 to the power of x plus 2 to the power of 1 minus x equals 3. Now at this stage you should recognize that this is a quadratic equation. And if there's a negative in your power, you're going to end up with a fraction. So you should have recognized, right, this is clearly a quadratic and I'm going to end up with a fraction at some point. I need to solve this by substitution. So we can say that y is equal to 2 to the power of x. Which means straight away my first term is just, instead of my first term, it's just a y. And clearly this is just a 3. So I have no problems with the first term or the last term, but my middle term is where my problem lies. Now I have 2 to the power of 1 minus x. According to your second rule of powers, a to the power of p minus q equals a to the power of p over a to the power of q. And I have 2 to the power of 1 minus x. So I have the left-hand side of this formula, and I want to go to the right-hand side. So I can just say that 2 to the power of 1 minus x is the same as 2 to the power of 1 over 2 to the power of x. And then remember, according to our substitution, instead of 2 to the power of x, I'm going to put in a y. Which means that this actually just becomes 2 divided by y. 2 to the power of 1 over y. So now I'm happy enough with that, because if instead of 2 to the power of 1 minus x, I can just plug in 2 over y. And now this question's a lot simpler because I've no powers. Now I can just go back to normal algebra. If there's a minus in your power, you'll always end up with some kind of a fraction like this. So I need to ask myself, what do I need to do in order to get rid of this fraction? Well, to get rid of this fraction, I need to multiply this by y. But if I multiply this by y, I'm going to have to multiply everything by y. So my next line is I'm just going to multiply the whole lot by y. Y multiplied by y is y squared. 2 over y multiplied by y is 2. 3 multiplied by y is 3y. So now I have a y squared, I have a y, and I have a number. So clearly this is a quadratic equation. If I bring my 3y to the other side, I'll get y squared minus 3y plus 2 equals 0. Now I can just factorize y squared minus 3y plus 2 equals 0. So I can just factorize this. I'll get y and y, 2 and 1 minus and minus. So y minus 1 times y minus 2 equals 0. So there are my factors. Now I have to go back and make sure that I solve it. So I can say that y minus 1 equals 0, which means that y equals plus 1. That y minus 2 equals 0, which means that y is equal to 2. Now, a lot of people got these answers and then for some reason eliminated the y equals 1. There's no reason why y equals 1 isn't a valid answer. Remember, I have no interest in my y. I need to find my x. So at the moment you're on 7 out of 10. You need to go back and find your x. So I originally said that y was equal to 2 to the power of x. So now I can say that 2 to the power of x is equal to 1. So that's my first one. Let's deal with this first, because a lot of people got caught out here. You have two options here. You could realize, right, my unknown is in the power. If my unknown is in the power, then I can introduce logs and solve it. But the easier thing to do here is to use your rule of powers that says any number to the power of 0 equals 1. So you should recognize that if this is a 1, I can actually rewrite that as 2 to the power of 0. So I have 2 to the power of x equals 2 to the power of 0. So clearly that means that x equals 0. So my first answer in that scenario is that x is equal to 0. To get my second value, it's a lot more straightforward. I can just say that 2 to the power of x equals 2. So I'm just taking my other answer here. 2 to the power of x equals 2. Well, clearly this is 2 to the power of 1, so it's just x is equal to 1. So my two answers in that case are x equals 0 and x equals 1. Okay, so question 3 here, it asks me to use the fundamental theorem of arithmetic to rewrite 2756 as a product of prime numbers. So basically, just keep dividing in prime numbers until you're left with only prime numbers. First thing you should recognize is that 2756 is even. And if it's even, then we definitely know that 2 is going to divide into it. So the first thing I'll do is I'll just divide 2 into 2756, and I'll get 1378. Now clearly 1378 is even, so I'm going to just divide 2 into it again, because 2 into 1378 goes 689 times. Now this is where the first stage where you really have to start basically guessing. Clearly 2 doesn't divide into it, so your inclination would probably be to divide in 3. 3 doesn't divide in, so then you'll try 5. 5 doesn't work, so you try 7. 7 doesn't work, so you try 11. You basically just try all the prime numbers. you keep going up with prime numbers, and the one that in this case that worked was 13. 13 into 689 goes 53 times. And then 53, again, your inclination will be you'll start dividing in prime numbers, and eventually you'll work out that 53 is a prime number. Now, a lot of you, I only gave 7 out of 10 here because you didn't list out your numbers at the end. So the last thing you should do is just rewrite it as 2 by 2 by 13 by 53. These are 4 prime numbers that multiply to give 2756. Now, finally, we can write it as 2 squared by 13 by 53. Now, you'll get full marks kind of for either one in this case, but I needed you to list them out. So for a lot of you, you found them, but then you didn't make it obvious what they were. So just leaving it in this format is not enough. I want 2756 as a product of prime numbers, but it needs to be written as all the prime numbers multiplied by each other. Now, I considered this to be a very long test, so I wasn't sure if you'd get time to do this one at all. But almost everyone actually did end up having enough time for it. So there was an extra 10 marks for this as well, so I've marked everyone out as 60. Now, I've recorded your results because I know I said I wasn't going to include it, so I've recorded both results. But notice the one I've given you in your test is out of 60, which includes this one. I consider this to be very difficult. I consider this to be as tricky as the logs ones will get. Okay, so I have 4 log by squared to the base b plus log the square root of y to the base b plus log by squared to the base b. Now, the key in this question is to distinguish between by squared and by squared. The fact that there's brackets there means that this is different to this. This means b to the power of 1 multiplied by y to the power of 2. This means b to the power of 2 multiplied by y to the power of 2. So you have to distinguish that. Which means that straight away in this one I can just bring my power in front. However, I can't do that in this one. So I'm going to just I'll take the first term, then the second term. We'll just do it individually. First of all, you should recognize that this is b multiplied by y squared. Okay, I can use my first rule of logs to split this up. So I have a 4 outside, and I can use my first rule of logs to split up my b and my y squared. So I can rewrite this as log b to the base b plus the log of y squared to the base b. Okay? Now, a lot of people missed out on the fact that if this number and this number are the same, then log b to the base b is just 1. If that and that are the same, then it's just 1. So I can rewrite this as 4 times 1 plus, and now because it's y squared, so all of this to a power, it's kind of in the same, it's y to be squared, which is kind of the same as what we have over here. We can just bring the power in front. So I can use my third rule of logs to simplify this. It just becomes 2 log y to the base b. And of course in the question it told me that s is equal to log y to the base b, which means that this is just 2 times s. So I have 4 times 1 plus 2s. 4 by 1 is 4. 4 by 2s is 8s. So my first term just becomes 4 plus 8s. Now I think the vast majority of you were okay with this one. I have log of the square root of y to the base b. Now remember, when we're dealing with logs, always have powers in the back of your mind. So with that in mind, you should realize that instead of writing this as the square root of y, I'm going to rewrite it as y to the power of a half. A square root is the same as y to the power of a half. Now I can just use my third rule of logs and bring my power in front, which means this becomes a half times the log of y to the base b. And remember, I know that s is equal to log y to the base b, which means this actually just becomes a half s. So that term simplifies down to a half s. And I can go straight on now to my last term. I have log by to be squared to the base b. Again, notice that means b squared y squared. So because it's the whole thing to this power, I can straight away use my third rule of powers, and I can just bring my 2 in front. So I can rewrite this as 2 times the log of by to the base b. And now I'm going to use my first rule of logs to split up the b and the y. So I can rewrite this as 2 times the log of b to the base b plus the log of y to the base b. Okay, so just according to my first rule of logs, I can split up the b and the y as log b to the base b plus log y to the base b. Now remember, I know log y to the base b is s, log b to the base b is 1, which means this just becomes 2 times 1 plus s, which clearly if I multiply it out is 2 plus 2s. And then my final line, I just need to group all my like terms. So 4 and 2 gives me 6, 8s plus a half s plus 2s gives me 10 and a half s. Okay, and in this case there was 10 marks, so it was 0, 3, 5, 7, or 10. Again, notice, if it looks like you had it nearly perfectly, I start you off on 10, and if you get one thing wrong, I go bring you down to 7, 2 things wrong, I bring you down to 5. If it looks like it's nearly completely wrong, I'll start you off at 0. If you get one thing right, bring you up to 3, 2 things right, bring you up to 5, and so on. Okay, so that's kind of the way it's marked in the leave insert. So I hope all this video made sense. If you're unclear on any of that, then just bring your test in to me in class tomorrow and I'll try and clarify it for you.